Unreal Engine Tutorials Part 1. Getting started. So, yeah, we're going to create a new Unreal Engine project. I suggest you, before you start, you find a local drive. You probably have the C drive. Make sure that you can write to it. So I've set up on my D drive, I've set up a Unreal Projects directory. You'll probably want something like, in the case of if you're at the uni, CS programs your username and then create an Unreal Projects folder underneath that. It's just good to organize your projects in one place, essentially. So you'll need the Unreal Engine launcher. So if you go to unrealengine.com, let's go back there, sign up for unrealengine.com, you'll create an account here, then you do the Get on Unreal button. That should install a launcher, and the launcher itself, when it loads up, it'll ask for your username and password, but once you've loaded in, it will actually create this launcher app. And the launcher is the thing that allows you to install the binary versions of the engine, and also manages your content that you bought from the marketplace and stuff like that. So what we're going to do is we're going to create a new project. Now, it's likely that you won't have the engine versions installed, so if you need to, you can just click the add versions button, and in that case it'll tell you, okay, there's 4.9.0 available, or whatever the current version is at the time you see this, and you can just click install on it and install that engine version. As it is, I've already got 4.8.3 installed, so I'm just going to run that one because we're not going to do anything complicated yet. So launch the engine from the editor, and then you can just close off the launcher. And we want to, in the engine, we want to create a new project. So you can either load existing ones that you've already created, or in this case we're going to create a new project, and it's got two tabs, and we want the C++ version of a project. So essentially what they've done is they've done a bunch of template projects, one set in Blueprint, which is their visual scripting system, and the other is in C++. So we're going to create a project, and I suggest we do third person because it's got a guy that's running around, which might be useful. The other options are not really important, but in this case, choose desktop, maximum quality from the two options available there. We don't want a mobile tablet game. And we can go with no starter content for now. You could choose with that, it doesn't really matter either way. That just adds some art files and textures and stuff to the project, so it makes it a little bit bigger. For now, let's go without starter content. And then make sure that your path to your project is right. So I'm going to do it to Deep Unreal Projects. You probably want CS programs, your name, Unreal Projects. And let's give it a name. Let's call it Practice Project 1. And then create project. So what that'll do is it'll generate the Visual Studio project initially. It'll also generate the Unreal Engine project and stick a bunch of sort of default files in there for us to use. You notice that it's compiling the source code for the project. Unreal Engine uses its own build system. It doesn't use Visual Studio for building stuff. So even though you're using Visual Studio maybe to edit it, it doesn't mean to say you're actually using that to build the code for it. So just be aware of that. So you noticed it loaded up Visual Studio. You can load up Visual Studio anytime. And it created this default project. So if you just click the play button and make sure it works, first time around it'll be compiling some shaders, so it might take a few seconds to get there. And yeah, okay, I've got a guy I can run around the level in. Okay, so what you should notice is that it's got a content directory, and the content directory is where you should keep most of your like art assets and those kind of things once they've been imported into the game, and all of your blueprints and scripts and anything else, and your sort of definitions of types and stuff. And then it's got the C++ classes. This didn't actually used to be this way in older versions of the engine, so you might see tutorials where this isn't the case, but for now it's got like C++ classes as well. So what we're going to do is we're going to add a new class to this. We're going to add a new type of object. Now, there are a couple of ways of doing this. Let's just have a quick look at the if we look at this project that it created, there's a few sort of default files that it's created, but other than that, if we actually look in the directory, you get a source folder and you get the Unreal project file. And if you right click on that, and this is something that might not happen in the labs, but you can certainly do it at home, but hopefully the labs will have this installed as well, there is the option to generate Visual Studio project files. So what's actually happening is that the Visual Studio solutions, the things that you load up in Visual Studio, are actually being generated by the Unreal Engine. What that means is that it's not Visual Studio that's adding and removing source files. It's actually this Visual Studio project generator. So just be aware that when you want to add source files, you'd put them in the source code directory in your project, but you would have to then run either with this generate Visual Studio project files, or with the engine itself. You could go to File and then refresh Visual Studio project, which will do the same thing. So just be aware that when you're adding files externally to the project, you have to go through this refresh cycle to do that. But luckily, when we're inside the engine, we can just do a new C++ class, and let's create one derived from actor first. So we select actor for our parent class, we select next. You notice it's going to put it in our source directory. Now we might want to sort of change how some of this stuff's structured, but for now let's just leave it as default. And we'll call it something simple like my test actor. So let's just create that class. And it's compiling. So there we go. It's compiled. It's compiled the source code, and you should have noticed there that it wasn't Visual Studio compiling; it was actually the Unreal Editor. And what happens is that the Unreal Editor monitors the files in the source tree and will compile them if it sees that there's a change. You can also hit this compile button, but we'll come on to that hot reloading issue later. So if you look at the Visual Studio project, what's actually happened is that Visual Studio has also refreshed that solution. So basically the changes that you've added, it's now loaded my test actor up. So you can do all of this stuff by hand. You can add your own C++ files by hand by just essentially adding them to the directory where your project is, the source folder, and it will, if you regenerate the Visual Studio project, it will add them to it. But let's just have a quick look through what it's created for this test actor. This test actor doesn't actually do anything yet. So going through the header file, first thing we see is that it's included the file for actor.h, so it knows what this actor class is. The next one is this generated.h, and what happens is that Unreal Engine auto generates a header file that it then inserts into the actor's header file using a thing called the Unreal Header tool. And the reason why it uses this generated thing is that when it looks through the project, it looks for specific macros. So like this uClass macro that we'll get into in a second, and generated body, it looks for those things, and when it sees them, it generates another header file that incorporates some functionality into this class. So when you're looking at Unreal Engine sort of C++ code, what you're actually getting is a mixture of standard C++, like all of these declarations, but also this kind of meta language macro stuff that runs through this other program called the Unreal Header tool and the Unreal Build tool, and gets added automatically to your classes. So you can't just create, well, you can just create classes, but if you want them to be recognized and used by Unreal, they have to have this kind of special macro language associated with them. And that's probably the first thing you need to sort of figure out, is how to declare all of this stuff and what it does and what you can do with it, because it's quite complicated in what it allows, but that's where a lot of the power for Unreal Engine comes from. So let's just go through the points here. So if we look at the file itself, the first part that we should see is this uClass macro. And uClass is the declaration of an Unreal Engine class. So the uClass is the sort of macro that says I'm now going to define, the thing after me is a definition of an Unreal Engine class. And what that means is that it sort of inserts a bunch of code to say this thing is a type of object that Unreal Engine understands. It adds a bunch of metadata, which both in this generated.h file and stuff like that. It decorates it with some extra information essentially. So these, sadly, this is all because the C++ language doesn't really include a lot of the functionality you need for a modern engine. So this is Epic's way of kind of extending the C++ language, but it just needs external programs to do that. It's certainly not what I would advise people to do generally, but I can understand why they've done it. So the uClass macro we will get onto at some point later in the course. Actor is one of the basic classes, and we'll cover what each of the base classes are probably next week. But the next thing is that we're deriving a class from Actor. You'll notice that all of the kind of classes that are derived from Actor, so anything inherited from that, have the A like name in them. So when it generated my test actor, it actually called it my test actor, and that's another thing that you want to keep an eye on, because actually that does the same kind of thing quite often. You'll sort of forget to use the A, and you'll try and use the name of the thing, and it won't come up because it's actually got the A in front. So what he's saying is there's a class declaration. It's of type myTestActor, and it's derived from Actor. Now there's this other thing here, which is this sort of define. Yours will be different. So depending on what you called your project, it's the name of the project and then _API. And what that is again another declaration, but this time it's a way of declaring the class as externally available. So by default, I would suggest that you include this in any of your sort of Unreal Engine class declarations based on what your project name is. So if my project was called, I don't know, engine test, I would have engine test _API in there instead. And this is it'll come up with errors and stuff when you don't. The trouble is, it's not actually defined inside the project. It's defined externally by the build process. So you might get an IntelliSense error if you've got IntelliSense installed and it's like highlighting stuff. But don't worry about that. Just use it essentially. Next part along is the generated body macro, and again you can right click and go to these things if you want to have a look at what they are. But the generated body macro again works with this kind of class declaration system. What that kind of means is that this object is available to the Unreal Engine reflection mechanism, and it's the reflection mechanism that's really the key to a lot of this stuff. So you can always have a look at what all of that stuff means if you want to dig into the source code of it. But again, you'll find that you have to remember to put all of this kind of boilerplate stuff in when you're doing a class, or you just do it straight from the Unreal Engine kind of editor, whichever way works for you. So it creates a default constructor. It's got two methods, and the two methods are begin, play, and tick. So to go into what each one of these does, these are obviously virtual functions. They've been overridden in this class. And what you should be looking for is in your implementation file, in the CPP file, most of the time when you're calling an Unreal Engine method, when you're overriding one, you want to call into the class that you've inherited from. And that's declared as this super class. This is coming from like a JavaScript, actually it's Unreal scripts, sort of naming scheme kind of thing. But basically it means call the thing I inherited from and call that function on it. So when you come to my version, it calls whatever the base class was going to do, and then you can add your own class information in here. So just be aware that because it's using inheritance, often you might want to call the base class's implementation to do like the default stuff and then specialize it, for yourself afterwards. Or you don't want to call that and you want to do something completely separate yourself. But that could have side issues because you're not calling the base class's functions. So just be aware of that. Another interesting thing to look at is the tick mechanism. So basically the tick function is a thing that the engine will call on an actor at a given interval. It says called every frame, but actually that's from 4.9 onwards, that's not actually true because you can set the frame rate of how often it ticks. But by default, actors, every frame, the engine goes through the list of active actors and says, right, if you're active, you should now tick, and it calls a tick function on it and passes in the amount of time that's passed. So if you want an actor that does something over time, then capturing the tick is not a bad idea. The other thing you need to enable the ticking is this bit of code here in your constructor. So what that means is there's this kind of data structure which has a b kind of a tick Boolean value in it. You have to set that to true so that the engine knows to call this tick function. So if you add a tick to something and you can't get it to work, make sure you've got this b kind of a tick thing set. And then finally the other function is begin play, and begin play is called when you actually run either from the editor in here by calling play, or when you're running it standalone, whenever it actually loads the level and your actor gets created, it'll get a begin play at start of like when the level starts essentially. So create your actor. Now when you've created it, you can start editing the code, and when we start editing the code, there are two ways of there are multiple ways of building, but one thing you can do which is kind of different is that we can edit the code on the fly and have the engine still stay up. Like normally what you would think of is if I'm running this sort of project is my project, why is there an editor running? Because surely I should run the editor from my project. And you can, but you don't have to. it's kind of a weird system, really. What happens is that the engine itself, A, you can start the engine and compile a project from there, or B, you can start the project from Visual Studio and start debugging it, and that will actually load the editor and load the project as well. So you can actually do it kind of both ways, which is probably a bit confusing. So just compile your project, and what you should see is that you've now got a MyTestActor C++ class in here. If you double click on it, you don't get anything because you've already got it loaded in Visual Studio. Now what we want to do is we probably want to, in our project, we want to now create something based on that actor. So we've got the class called, what the hell did we call it? MyTestActor. What we probably want to do is we want to create a new blueprint. Now, when we're picking a parent class, what we can now do is we can actually create a blueprint based on our MyTestActor class. So if you think of the class that you've got in here, the sort of MyTestActor code, that's the sort of basic object type, and when we're creating a blueprint, we're creating an instance of that, or rather like a sort of template to use that class for something. So let's just add that into the world, and we'll call it MyTestActor BP. It's useful to have naming conventions set up for things. And now when we double click on that, so the blueprint, it kind of gets confusing because blueprint is the language that they use in like the event graph thing, but blueprint is also kind of the system they use for templating objects. So you'll see that by default the MyTestActor has a default scene root, which is basically like an empty thing, and in the blueprint for MyTestActor we can start adding stuff to it. So like we might want to add a static mesh, for instance, and if we go to here we can choose a mesh, I don't know, a cube say. Yeah, so we can add components to this thing, and then what, let's say we let's tell this to simulate physics, so it's got physics on the cube. And then we can drag one out into the world, and when we play, our physics cube drops into the world. So that physics cube is a blueprint based off our C++ class. And that means that our C++ class, we can implement all sorts of functionality in this code here, and this thing would have that functionality available to it. So that's the basics of creating an actor. You create the C++ class, you then create a blueprint based off that C++ class, and then you can edit that blueprint whichever way you like. You know, you can add things to it in terms of components, you can respond to events in the actual blueprint script event graph, you can set the properties of the C++ code if you've got available properties that you've exposed to the blueprint, that kind of thing. So that should be, if you've added the static mesh, switched on the simulate physics, compiled and saved the blueprint, you should be able to add any number of those things that you want. So just see if you can get to that point. Add the class, make sure you've got a blueprint of it, and then we'll add some code to make it do something. So get yourself up to speed with that, and then we'll do the next part of the tutorial.